Now we are going to explain the breaker failure protection function. We'll open here setting, breaker failure protection. We'll find all bay units. You can access any bay unit and put the setting for the breaker failure function. Here in the manual, he's telling you the breaker failure function in the bay units monitors the phase currents independently of the busbar protection. They have two timers with individual setting, T1 and T2. The operation of the breaker failure function is enabled either internally by the busbar protection or externally via binary input. External via binary input may be this one electrically or mechanically, like in transformer bay units. Okay, then here he's telling you after the first time delay has expired, a tripping command can be applied to a secondary trip coil on the circuit breaker, and a remote tripping signal transmit to the station at the opposite end of the line. This one means the trip command, the first trip command, is going only on the first trip coil of the circuit breaker. Then if the circuit breaker fails to trip, again the breaker failure function will give a retripping signal after the elapsing of timer T1 to the second tripping coil of the circuit breaker. Again, if the circuit breaker fails to trip, then a remote tripping signal must be transmitted to the station at the opposite end. Actually, the remote tripping signal can be configured in the software to be transmitted after the first or the second timer. So if we bring again the software, we'll find here the function can be activated or deactivated from this setting. Here we'll put our setting current according to our format. We'll open format. We'll find the current threshold for the breaker failure is 0.1. Time delay for the first stage 120 millisecond. Time delay for stage 2 from stage 1, from the end of stage 1, 120 millisecond. So here we'll put the setting here 0.1, and the time delay here is 120, and the time delay here also 120 from the end of T1. If we remove T1, it means T1 is not activated, and the signal related to this timer will not be activated also, but we need T1 and T2. The remote tripping can be selected to the signal be activated with T1 or activated with T2. So the remote tripping actually will be with T2. Then you press apply, then OK. Then we have to configure our signals. We have BFB trip T1 and BFB trip T2. These two signals as a central unit. As a general signal, there is a breaker failure function, and there is a retrip command generally in the substation or any bay unit. But in the bay unit itself, we will make binary or assign binary output and LED with a BF trip. This one's a BFB stage 1, breaker failure protection stage 1, and we have BF remote trip, this one with stage 2. Then we have the initiation, electrical initiation, start BFB L1, L2, L3, and we have external start BFB, this one mechanical breaker failure initiation like in transformer bays. And we have one binary input with trip transferred, means circuit breaker faulty, circuit breaker not ready, circuit breaker defective. So we'll come here, configuration, binary module, we'll open the central unit, outputs, then we have to add the two signals already available, BFB trip T1 and BFB trip T2. Then we'll go to the bay unit under the test, for example any bay unit, and we'll come here to the output contacts. We'll find the BFB trip, BFB trip, this one for the first stage, and BFB remote trip, this one for the second stage with this address 23105 and 23110. This one available already here, 23105 and 23110. This one's the output contacts, but at the same time also we need inputs already available, the inputs here. start BFB L1 L2 L3 and the trip transferred. For the mechanical initiation tripping, leave this one now because this one need a small modification. Okay, then apply, then okay, and then I will go to configuration LED. On the central unit I will add BFB trip T1 and BFB trip T2, then okay, and then I will go to my P unit. I'll find BFB trip and BFB remote trip. All of them I can make all of them non-latch. Then apply, then okay, and then file, download to protection system. We'll open the format again. Then we'll check our table. Here, if the binary input start BFB L1, L2, L3, this one for the electrical BF initiation. If this binary input is activated and the P unit current greater than 0.1 ampere at any phase, the binary output, which is BF trip, will trip after 120 millisecond, and the binary output BF remote trip will trip after 240 millisecond. Okay, our table now, we need to get the pickup, drop off, and timer T1, timer T2, and the circuit breaker faulty, the tripping delay in case of circuit breaker faulty. So first we'll make the timer T1 and the T2, or we can say T1 only. We'll come here, configuration, setting, breaker failure here, and this one, the minimum value here is 10 millisecond because we are making pickup and drop off. You can make it 10 millisecond, or when you are or you can keep it at 120, but when you are getting the pickup and drop off, you have to increase slowly, gradually, until check, because the pickup will be delayed by 120 millisecond. Because we don't have signal with pickup, we have signal with tripping after T1 and tripping after T2. So you can increase the current gradually, slowly, until the BFB trips this signal for T1, or you can BFB trip T1 on the central unit LED. If you indicate this one, it means this one is picked up. Then you will get drop off, pick up, drop off, pick up, drop off for all the three phases. After that, we'll use the output contact, which is BF trip, and the other output contact BF remote trip, to measure the current T1 and T2. So also using the Fraser from the third page, for the first page you will inject 0 voltage and 0 current, and the second page you will inject the current at phase L1 only, more than 0.1 ampere, and then you will inject from the third page, and you will make the first page time delay only 1 cycle, and second page make it high cycles, no problem, high number of cycles. And we will use the binary output of the Fraser to inject a binary input on the relay. In this case, you will give the relay as initiation from start BFB L1, L2, L3, and there is a current more than 0.1 ampere. So after 120 millisecond, it will close the contact BF trip. You will do the same for L1, L2, L3, and then use the other output contact. For the second stage, it will close after 240 millisecond. Then, in case you have the binary input trip transferred is activated in the same time with the start BFB, the second stage, which is BF remote trip, will trip instantaneous trip only as a binary output, which is called BF remote trip. But the binary output of the retripping, which is called BF trip, this one will never trip. It will not trip, it will not close. This signal will not be activated. Only the signal for remote tripping will be activated, and the time delay will not be 240, it will be instantaneous, as we have the circuit breaker is not ready. By this way, you finish the test for the breaker failure. But there is some checking, you have to some cases you have to check it. In case of circuit breaker faulty, you will find that the output contact, which is called trip, as we said before, this one busbar tripping or breaker failure stage 2 from other circuit breakers. This trip in your bay, it will not trip, but it will trip at all other bay units connected with my bay at the same bus bar. It means this one will not trip at the bay unit under test, and at the same time transfer trip will issue also to trip the remote end. Okay, it means in my bay unit, I will hear from the configuration. In the output contact, I have already this signal which is called trip. I will assign this signal with LED. It's already available here. In case I have trip transferred and then I have breaker failure initiation, the current is more than 0.1 ampere, more than my setting, the BF remote trip will instantaneous trip, and this signal will not activated in my local relay on my bay unit that I'm injecting at. So this LED will not come. But if I have any other bay unit connected with my bay unit on the same bus bar, I'll find this LED which is called trip on the other bay units are activated. So now I'm sure that in case of breaker failure second stage, the central unit will send tripping for all bay units available or connected with my bay unit on the same bus bar, and the other bay units which is connected to the other bus zones will still healthy, and there is no tripping command going from the central unit to these bay units. Okay, this one only fast checking for the breaker failure. Okay, what about the external start BFB mechanical breaker failure initiation? The problem in this signal is that if the breaker was open, the breaker status was open, and the current is less than 0.1 ampere, and just you give this binary input, the relay will calculate T1 and then close the signal, close the output which is BF trip, and also after T2 he will close BF remote tripping. Even the breaker was open or the current less than 0.1 ampere. So this one need modification. We will not use this binary input signal. So how we can solve this problem? Only for transformer bay unit only. For transformer bay unit, or we can say the mechanical initiation, we are depending on the breaker status, not the current status. This one is called the low current mode. So for the low current mode, we now need the breaker status. For the electrical breaker failure initiation and the internal breaker failure initiation from the busbar protection, all these cases depend on the current only, not depending on the breaker status. For the mechanical, I cannot depend on the current. I have to depend on the circuit breaker status. But actually in this relay there is a problem, is that this signal doesn't depend on current or on the breaker status. Not this one and not this one. So we have to modify. This binary input, we can connect it as a hard wire in series with the circuit breaker status. So now if this binary input came and the breaker was open, the breaker failure will not issuing a retrip or backup trip. But if the circuit breaker was closed and this binary input came, as the two signals are in series and connected to this binary input, in this case the retrip and backup trip will be issued. Okay, so this one way by a hard wire, or you can make it through the software here. Close everything here and we'll open setting, bay protection. We'll choose the transformer bay, for example this one is a transformer bay, then open. We'll use here the logic gate. We'll drop this one from here to here, and we can give name for this one as a mechanical CBF. Okay, this one like a groups So this one activated all groups, no problem. And then press double click on this one. The logic mode, we need it AND gate. Is asking you blocking. You need to block this function, always false, means 0. And then we need to take two signals as AND gate. One signal is the external initiation, and the other signal is the circuit breaker status. And instead of making it hardwire, we are going to make it as a software. So we'll open this one. It's telling you need always 0 or always 1. Not 0, not 1. I need the signal which is called initiation. So I will go to output from function here. This one, some fixed signal available, you can use it, but I don't need. I need general purpose signal. First one, I can say this one, mechanical trip, and then press OK. Then the second one, also output from function, general purpose, and I will use here CB close status. Then OK. Then here this one and the gate. I cannot leave this one always false, so I'll keep this one always true, means 1, and this one also always true. Then I press OK. Now for this function, this is AND gate. Here there is a general signal called mechanical initiation or mechanical trip, and here circuit breaker status. But actually, from where this general signals? So I'll close this one and I will open here setting, configuration, binary module. I'll go to my pay unit, and here as a binary inputs I'll make new signal. Here, sorry, pay protection. Where is the signal? Signal not available here. Again, we'll open this one, setting, pay protection. Oh, this one is not saved, sorry, we will make it again. And the gate, we'll say this one, mechanical CBF, available here and here and here. And then double click. We'll choose this one as AND gate. The last two signals always true, and this signal output from function general, and here mechanical initiation, and then OK, and also here CB close status, then OK, then OK. Then I will go to this function. This one's a fixed function, set the relay, and here this one, the output from this function, the output from this AND gate. When I press this here, double click, this one, the output from the AND gate of the function of this one, I need it to be with the external start BFB. So I press here edit, not always false, not always true, output from function, and here I will find the AND gate that I will make, that I made it already, which is called mechanical CBF. So I will use the output of this AND gate, then press OK. So now the output of the AND gate will be internally as external start BFB. Then press OK, then OK. Then here open configuration, binary module, and we'll choose my transformer pay. Here as a binary input, new signal, pay protection. I'll find here the two signals coming now, mechanical initiation, CB close status. So I will put the CB close status. Actually the circuit breaker close status here is coming at 6. So this one also I'll put it at binary input number 6. Then again go to overview. So here the close status will be the same, the close status, and another one for the external initiation. So I'll make new signal, bay protection and mechanical initiation, and I'll check where is the mechanical initiation here. Actually I'll choose any binary input I need. For example, binary input number here 7, 8, we'll choose number 8. Okay, apply. So I have now the breaker status, close status, and the start and the mechanical initiation. So if this binary input and this binary input together on the AND gate, apply, then OK. Bay protection. So now if this binary input and this binary input came on the AND gate, and this one is also is true and this one is true, the output of this AND gate will make external start BFB. Means this one's for the mechanical initiation internally, and by the same way you can test your function, but here without current. Here by circuit breaker status, one time you will give the binary input and the circuit breaker status is open, and the other time you will give the binary input and circuit breaker is closed, and you can inject this binary input through the Frege outputs, and you can in the page 1 and page 2 you put the current and voltage, everything is 0, and only the test is through binary input. One time binary input with circuit breaker is open, so there will be no retrip and no backup trip, and another time you will inject both binary outputs from the Frege together, the initiation, the mechanical initiation and circuit breaker status closed, so the relay will stop. If you are using the output contact which is BF trip stage 1, it will stop after 120, and if you are using the other output contact it will stop after 240. This one is the only for the transformer, this one only small modification, but this one is very important if you need low current mode, because you cannot use this direct binary input, as I told you, because this binary input has a problem in this relay, that if this binary input came, the relay will give the retrip and backup trip even the circuit breaker was open and the current was lower than the setting current, because this one not depending on the circuit breaker status and not depend on the current mode, so we have to make this modification. And by this way the circuit breaker failure function is finished.